Previously in Journey to the Death of the Universe, during the episode The Birth of Our Solar System, we discussed how everything around us came into existence, including the Sun, Earth, Moon, and other planets. Today, we're going to talk about how Earth first saw the emergence of life, how you and I relate to the first organisms, and how everything came to be in life on Earth. Did you know that Earth has faced 8 mass extinction events throughout its history? I'll discuss that in a separate video, so make sure to subscribe if you want to learn more. About 4.5 billion years ago, Earth had just formed and was a molten, volatile world. Over the next few 100 million years, the planet gradually cooled, forming a solid crust. Volcanic activity was rampant, releasing gases like water vapor, carbon dioxide, methane, and ammonia, which helped form Earth's early atmosphere. During this time, water, possibly delivered by comets and asteroids, or released from within the Earth, began to condense, forming vast oceans. It was in these ancient seas, under a protective atmosphere, that the conditions for life slowly emerged. Around 3.8 billion years ago, the first signs of life appeared on Earth in the form of simple, single-celled organisms. While the exact process remains mysterious, scientists believe that organic molecules, such as amino acids, may have formed spontaneously from simple chemical reactions, possibly in deep-sea hydrothermal vents or shallow pools near volcanic activity. These organic molecules eventually assembled into more complex structures, like proteins and nucleic acids, forming the first primitive life forms, likely anaerobic bacteria. Among the earliest fossil evidence of life are stromatolites, layered structures formed by colonies of cyanobacteria. These microbial mats thrived in shallow waters, trapping sediments and building up over time, leaving behind structures that date back to at least 3.5 billion years ago. Cyanobacteria were not only resilient, but revolutionary, as they were among the first organisms to perform photosynthesis, a process that would eventually transform the planet. As cyanobacteria multiplied and spread, they began releasing oxygen as a byproduct of photosynthesis. For hundreds of millions of years, this oxygen was absorbed by the oceans and reacted with dissolved iron, creating vast deposits of iron oxide. But around 2.4 billion years ago, oxygen levels in the atmosphere began to rise, a period known as the Great Oxygenation event. This marked a pivotal shift in Earth's history, as the increasing oxygen levels created a more hospitable environment for new forms of life, but also led to the extinction of many anaerobic organisms that couldn't survive in oxygen-rich conditions. After the Great Oxygenation event around 1.8 billion years ago, the first eukaryotic cells appeared. These were more complex than the earlier prokaryotic bacteria and had a defined nucleus and internal structures like mitochondria. Some scientists believe that eukaryotes emerged through a process called endosymbiosis, where one prokaryotic cell engulfed another, leading to a symbiotic relationship that eventually evolved into more complex, multicellular organisms. For billions of years, life on Earth remained primarily microscopic, but around 540 million years ago, something extraordinary happened: the Cambrian Explosion. This relatively short period of evolutionary history saw an explosion of diversity in the types of life forms, with many of the major groups of animals appearing for the first time. Multicellular organisms evolved rapidly, developing specialized tissues and organs, and Earth's oceans became home to a wide variety of complex life forms, including early ancestors of today's animals. The next episode will be the last in the series, concluding with the end of everything: our planet, solar system, galaxy, and the universe. So this is Journey to the Death of the Universe, episode 4. See you in the next one.